Hi, in this video, I'm going to demonstrate Flomesh Service Mesh or FSM in short. FSM is a Service Mesh Interface SMI compatible, lightweight service mesh for Kubernetes East-West and North-South traffic management. Out of the box, it provides ingress, namespace ingress, egress, service load balancer, Kubernetes Gateway API, Kubernetes multi-cluster, eBPF as an optional replacement for IP tables, and more. In today's demo, I'll start with download the FSM CLI, install and configure from a service mesh or FSM on Kubernetes, install a demo application, and we'll see how to configure traffic policies, how to perform canary release using SMI traffic split, and we'll set up a ingress rule using a Flomesh ingress controller, and we'll take a look at the Grafana and Jaegers as a dashboards. So let's get started. To start with, we need to download the FSM CLI that is available on the GitHub. Navigate to the Flomesh IO FSM repo. Move to the releases page, and here we'll just download the latest one. So the current version is 1.1.0 and we'll be using that one. So it offers multiple platforms, but my VM is running on Linux on AMD architecture. So I'll be just downloading that one. I'll just copy the link and I'm going to move to the terminal now. Just download. We have downloaded the CLI. Unzip it. So it will be unzip here. There's the FSM. For easy access, I'm just going to copy this FSM to my user local bin so that I don't have to provide the path. Okay, let's see. Right, the FSM version you can see. All right, so it displays the version information. Client version is v.1.1.0. That is what we downloaded. And another message, error message, you see that unable to find FSM control plane. That shows actually it is unable to connect to a Kubernetes cluster. It can connect to the Kubernetes cluster, but it doesn't find any from a service mesh control plane. And that is what we are going to do next. We are going to install a FSM control plane. So here what I'm doing here is I'm using the same FSM CLI which we downloaded now, and I'm invoking an install command, but I'm passing this configuration options here. Mesh name, that is the name of the mesh. You can have multiple mesh on the same cluster. So this is the name that's going to distinguish. And FSM namespace. You can provide any namespace where you want to install this control plane. So I'm just going with FSM system. And these are the options, configuration options. The first one is enable permissive mode. That is the suggested one, a required one for the brownfield deployments. Here we are actually asking it, FSM, to don't enforce any SMI policies because the default SMI policy is decline. So for brownfield deployments, we definitely don't want to interrupt existing communication between the services or the pods there. So that's what we are doing here is, so we are going to start with this in a permissive mode so that all the communications can happen between the services, and later we are going to deploy or define SMI policies so that only targeted services they can communicate. So that is one. And we'll be using the Flomesh ingress controller. So that's what I'm setting here. FSM ingress enable true. And I'll be deploying Prometheus, Grafana, and Jaeger for metrics purposes. And because we are deploying a Jaeger, so we need to enable a tracing. So let's start. It's going to download and install the control plane on your Kubernetes cluster. So it has already installed Jaeger, Prometheus, Grafana, and the Bootstrap. Now it's installing the FSM controller and injector. It might take some time depending on the network speed. So we're almost done. We're installing the ingress controller. Okay, this is complete. Let's do a double check. It is the namespace where we install this control plane and see all the parts, they are up and running. Okay, so the next thing we need to do is we are going to deploy a demo. We have our control plane, service mesh control plane installed, but we don't have any applications running, so that we can manage by our service mesh. So what we are going to do is we are going to deploy a sample application. The sample application is available on the documentation sides of FSM, and you can follow the steps there. And I'll be just using the same sample applications to deploy. So this sample application we are going to deploy consists of 5 different parts. One is the book buyer, and that is an HTTP client, and the book thief, that's also an HTTP client, but that's also going to make requests to the bookstores to steal the books, right? And then we have the bookstore service, that is the server point, and book warehouse. A book warehouse is actually a kind of data store, and only bookstore should be applied to communicate with the book warehouse, and we'll be using MySQL as a backend database here. So that's all. For us to start, we need to create the individual namespace. So we'll be just deploying the applications into its own individual namespaces there. So let's start with creating a namespace. I need to clean my screen. Yeah, for just to make sure our control plane is installed and working, we can also just do again version. So here now you can see it's displaying the information of the control plane. Our mesh name, we give it the namespace where it installed and the version, right? So let's just create a namespaces there. So I just copied my command here, and we created here 4 different namespaces, right? Bookstore, book buyer, book thief, and book warehouse. Now the namespaces are created, and these are separate namespaces, right? So for us to for the Flomesh FSM control plane to manage these namespaces, we have to tell FSM, please manage these namespaces. So watch these namespaces. So whenever any uh, application is installed into this namespace, control plane is going to inject the sidecar proxy. So for that work, what we have to do is, again, we have to use the FSM command line, and we just set FSM namespace add and the names of the namespaces there. So this is now managed by FSM. We can just double check that. FSM namespace placed, and here you see that one sidecar is enabled. So what it does is actually it's just going to label a namespace, the Flomesh IO monitored by FSM, and also going to add an annotation for the sidecar injection. So here you can see we just added the labels, right? And we also added an annotation. Okay, so now let's start with deploying our applications or the services. First thing, we are going to create a book buyer, and we'll be creating a service accounts and deployments. Again, I'll be using the same demo which we have available on the documentation site. Okay, so we create book buyer, we'll go with the book thief. Similarly for the bookstore, book warehouse. Okay, it shows it has them installed. So let's just do a quick test of what is installed. We're going to check the book buyer, and we're going to get the parts, deployments, and service accounts. Okay, so we can see it's up and running, and these are the things there. Why we are doing it that one? Actually, we are creating a service account, and this service account will be used to identify as an identity, and that identity will be used when we are going to set control policies or access control policies. We can do double check for all of them. Application is up and running. Right, so things are there. Now what you can do, we're going to watch, which we're going to see how our application look like. That is the first thing, just to see that, so we are not going to set up ingress rules just to make things simple. What we're going to do is we're just going to do put forward. So I'm just using a script that's provided in the FSM repository, and I'm just going to do a port forward for book buyer, bookstore, and book thief. And here you can see actually they are running on 8080. So the book buyer is running on 8080. So let's just access, try to see how it looks like. 8080, and I'm going to use the same port 8083. This is book thief, book buyer, book thief, and next port is 8084. This is a bookstore, right? So you can see actually the counter is working right. So, and that is the reason actually, because we are started with the permissive policy. So now FSM, the control plane, is actually taking care of all the communication between them. So you can see book buyer, book thief, thief is stealing, and buyer is buying the books, and this is the bookstores that is actually communicating with the book warehouse. Okay, now what we need to do is, because now currently book buyer, book thief, but that's not our, we need to control policies there so that we don't allow book thief to steal books there. How we can do that one? What we are going to do is, first we are going to start with disabling our permissive mode, policy mode. So what I'm going to, I'm just patching that our mesh config, and I'm disabling permissive policy mode to false. Once this is done, we can go back to our browser, and we'll see that actually the counter should stop. So this policy has actually enforced, because what we said in the beginning, right? The SMI, the default policies decline all. So none of these services or applications are able to communicate. So that's what we see, the counter has been stopped. Okay, now what we are going to do next, because now our book buyer and bookstore, actually they should be communicating, but now they are unable to communicate because we have enforced that decline all the policies. And now we need to use our SMI, a service mesh interface, traffic access policy, so that we can allow this book buyer and bookstore to communicate with the book warehouse or the bookstore. So let me move back to my terminal and to apply traffic access policy. You can take a look at the YAMLs there. So So we have created, you see we created the traffic access policies using the SMI specs. And now if we go back to our console, we should be able to see the book buyer, the counter is working. Book thief, there is no increment in the counter because our this access policies only allowed book buyer and bookstore. Okay, so that is how to apply a traffic access policies to allow the services which you want them to communicate. So the next thing we are going to demonstrate is how to perform a kind of canary release. So for that to work, what we are going to do is we need to install another version of the bookstore. Okay, let's call it bookstore v2. This is the same as bookstore v1, but just give it a label as v2, and just to show that actually this is another service, maybe with a new functionality or some other functionality, because we're just giving a demo here so that it shows. Let me stop this one because currently we don't have this demo or the port forward working for our v2. So we'll use the same scripts, but we'll also enable the port forwarding for our new service. Okay, same port, but we added a new one. 8080 is the book buyer, 8083 is book thief. I'm just going to copy this one again. 8084 is bookstore v1, and the other one is 82. This is the big store, right? This is the new service which we deployed. Now you'll be confused. Why is that one or this newly deployed service is able to communicate, right? So because you can see the counter is increasing. The reason behind that one is that we have actually done the labels. If you take a look at the YAMLs there, right? So the label is actually set for the version v1 and v2. That's why we are able to see that, bookstore version v2 is able to communicate. To stop that one, we're going to apply a traffic split policy terminal. Here we go. So I'm going to apply a traffic access policy. Traffic split policy. Now what it's going to do is actually it's going to split the traffic, and it's just going to send the traffic to only bookstore v1. So that's what we see that here the bookstore v1 counter is incrementing, but bookstore v2 version is not, right? So that's not able to access the service. And the book buyer is similarly the same thing, right? So what we did is we just created a traffic split policy. Now the next thing is actually let's do a quick way of applying a 50-50% traffic rates policy and get that connected traffic rate. You can see the backend there, right? So the backend is currently only one bookstore v1. That's what we just applied now, right? And sending all of the traffic to v1, and that was the reason actually we are unable to see that v2 is unable to receive any traffic. The next policy we are going to apply traffic split is we're just going a 50-50%, so that the 50% traffic is routed to v1 and 50% traffic is routed to the v2. Now this policy is configured. Just do a double check. Here you can see v1. Now we have two different backends, v1 and v2, and the weight is 50-50. And this now should be able to counter should be increased. You can see here counter is increasing. Similarly here the counter is increasing. So that is how you perform a kind of canary release. Now we are okay. Now we are good with this setup, and we know our v2 service is up and running. So let's just do a kind of redirect all of the traffics to our v2. So we can apply the same policy, create another YAML, and just apply the traffic split policy. And if we take a look at that one, what we did is actually we just increase the weight of the v2 and we decrease the weight of v1 to 0, so that the v1 should no longer be able to access the services there. If we take a look at that one, this is our v2. This v2 is working. If you go to the v1, you can see v1 stopped. Right? The counter is not incrementing. Look by these are the same. Okay, so that's all. Let's stop this one. So that shows actually how to perform a canary release. So definitely SMI offers, kind of backends are the selections criteria based on your own different requirements. So how you want to do the settings. Now let's just do a quick, ingress setup. I'm going to clean it. Okay, so here what we are doing. We are creating a normal ingress rule for our bookstore v2, but what this ingress backend is, because our services are running in the service mesh, right? And the default policy is external services, they are unable to communicate with services running inside the service mesh. And for the ingress traffic to access the services running inside our service mesh, we need to provide an ingress backend. That is actually a CRD provided by the FSM. In that way, actually, we are going to provide a trusted source. So telling the service mesh, any ingress traffic coming from this trusted source to this target should be accepted. And that's what we are doing here. We are creating an ingress backend. And similarly, you see our backends is the same service, v2, but now we are telling you the source, and any ingress controller, any service, any ingress traffic coming from this ingress should be accepted. Now that is done, let's see if now we don't need to access these ports because we created an ingress, and my ingress is running in this public IP, and I should be able to access my v2. That is how you do it. So ingress controller is similar to how you are used to that. That's the standard Kubernetes ingress controller. So you just follow that one. And okay, so now let's just take a look at that part. We call it Grafana. I'll be still using the same scripts, port forward. Let's call it Grafana. Now 3000. So this is the one Grafana which we installed via our FSM CLI. And to access this one, dashboard, go with the admin, password also admin. For the first time when you log in, you'll be asked to change the password, but we won't be doing that once we escape because demo purposes. So now here you see the dashboards that comes with Flomesh Service Mesh provides different kind of dashboards you can access. So just let's have a quick look up the IP details. So here it shows the number of namespaces that was being monitored and the CPU usage and so on and so forth. So these are the dashboards which you can access. Now let's just see the Jaeger, because we enable the tracing. So we see that if we are able to access our tracings, use the same script forward. I will call it here. Jaeger port is 668. I'll just go. We are able to access our Jaeger. Take a look at it. That is the tag of our services deployed. And similarly, we can do a search of it. We store. Okay, let's go with this. Find the traces. So these are the traces. You can access any of them. Just get the more details. Feel free to play around, and if you have any questions, please reach back to us. That's all from my side today. Thank you for watching.